Hi everybody, this is day 3 of the unit. We're going to be talking about absolute value functions, which you've done in the past, and then something new, piecewise functions, which is brand new to you guys. Piecewise functions are something you will definitely see in calculus if you're headed there. If we're following along the plans, this would be the day to follow. This is also listed as a picture on the first day of this unit on the stream of Google Classroom. So this will be your homework to complete by Tuesday. So absolute value graphs. Remember, absolute value, these vertical lines here, mean the distance from 0. So when I say the absolute value of -2, the answer is 2 because it's 2 spaces from 0. The absolute value of -1 is 1 because it's 1 space from 0. And since distance can't be negative, that's why the absolute value of a number is never negative. To put something like this in your calculators, there's a number of ways to do it. Once you're in the y equals, I usually go to second catalog. Catalog is the 0 button on your calculator. And that first option, ABS, is what you want to choose. Press enter and you'll see those absolute value bars. The older calculators will keep them as parentheses and it'll say ABS on it, but it's still doing the same thing. So the absolute value of x is what I want to graph. And there it is. And of course you can get your table of values by going to the table. But now that we've got our graph over here, we're just going to go through some important points about it. Domain and range is something that we've done for all graphs all year long and in years past. The first question I ask myself for domain is the graph going right and left forever? If it is, it's easy, and if not, we just need to narrow it down to where we do see it. If I look at this graph, it is going right and left forever. It's gradually opening up so it goes right and left forever. That's negative infinity to infinity. Remember, the parentheses mean don't include the infinities because you can't ever touch infinity. The range, now it's not going up and down forever, so we have to figure out, well, where do we see it? So on the y-axis, I don't see it down here at all. I see it starting at the y value of 0 and going up forever. So bracket 0, comma infinity. Where is this increasing and decreasing? The intervals where I see this graph increasing are from 0 to infinity. And where do I see the graph decreasing or going down? And by the way, when you're looking at increasing or decreasing, look from left to right. So the graph is going down from negative infinity to 0. Okay, so that's what increasing and decreasing stands for. Symmetry. It is symmetric about the y-axis. You can see if I fold in the y-axis, both sides would match up. And if you guys remember, a function is considered to be an even function if it is symmetric about the y-axis. So we can say that this has even symmetry, and it's an even function. Where's the graph continuous? If you want to know what that means, if I just put my pencil tip down over here, for example, starting at the leftmost spot, and keep tracing the graph, do you see how I don't have to lift my pencil up? I can keep following it. So this graph is continuous from negative infinity to infinity, and that's all that means. So now I want to introduce something new to you called a piecewise function. So a piecewise function, that's a topic that will definitely come up in calculus for you. It's taking a look at a graph in pieces. So right now I can define this graph as the absolute value of x, or I can think of this graph as 2 different lines. Like, see here, if I continue this graph like this, it looks like a line, right? And if I continue this line over here, so I can rewrite this equation as 2 different lines. I just need to tell you specifically what intervals to look at to see this part of the line and what interval to look at to see this segment of the line. So let me just show you what it looks like finished, okay? And then that'll be easier. So if I want to define that graph above as the line -x for all x values less than 0, and I want to define that graph above as positive x when x is greater than or equal to 0. Let me just take a look at my calculator here, guys. if we just type in, clear that out, the graph negative x and the graph y equals x, do you see how we get two lines that intersect? And basically, if I could just erase this bottom part, quadrants 3 and 4, it would look the exact same as the absolute value graph, right? That's what we call a piecewise function. So the graph above, that absolute value of x, is the same graph as this one here, but only when you look at the graph of negative x, that's the negative slope line, for all x values less than 0. So I'm only looking at this graph of negative x for the x values less than 0. That's this part. So essentially you erase this part here. And the graph y equals x, this diagonal line right here, I'm only looking at that for all x values greater than or equal to 0. So starting here and going this way. So essentially erasing this part here. So the thing about piecewise functions is that you can take pieces of different graphs, say negative x and x, and make it look like another graph, okay? One other thing I just want to say about this over here, one of these has to have the equal to, otherwise you wouldn't have that point right there at the origin. It wouldn't matter which one got the equal to, okay? And just because we've been talking about this throughout the unit, how to shift a graph, that's something that works for lines, for parabolas, for cubics, for anything, okay? Always remember that the number in front of the absolute value or in front of the quadratic, a cubic, whatever, that is going to tell you whether or not the graph is flipped over its vertex or turning point. So if it's positive, the graph is going to look like this, positive. It smiles at you, kind of like a parabola, right? And if this a value were negative in this graph, that were negative absolute value of x, this graph would be looking like the bottom half here, like the letter A more, not the letter V. Remember, when you add or subtract to the x variable, that moves the graph right or left. If it's moving left, it's got a positive, and if it's moving right, it's got a negative. And if you add or subtract a number to the end of the equation, I can say plus minus here, that moves a graph up or down. So those are just basics of any shift or reflection. So keep that in mind. That works for every single type of graph, the A, B, and C values I'm talking about. Just so you get one more example. So if you were to type this equation into your graphing calculator again, and mind you, remember, you don't have to type in your graphing calculator. If you made a table of values and start plugging in for x, you'd find out what the y value is or the f of x is, and you could create your own graph. Don't think that you always have to plug into your graphing calculator to get a graph. So I'm going to type in the negative first. Remember, the negative, use the one by the decimal point. So second catalog, which is the 0 button, absolute value, x minus 2 plus 4. Now before I hit graph, I just want to keep in mind a couple of things. I see that negative in front, so that means the graph is going to go from looking this way to looking more like this. I see a number is being subtracted from the x value, so subtraction means we're moving right. And here at the end, if you add a number at the end, or the graph is going to move up. So in comparison to the original graph we did on the previous side, the absolute value of x, the plain old graph of absolute value, this is going to be reflected over that vertex. It's going to be moving right 2 spaces and up 4. And if I hit graph, we can see that we reflected over. Instead of that vertex being here, it's moved right 2, up 4. And there it is. And I've got it all graphed out here as well. Domain goes right and left forever. Range, I see the graph exists from negative infinity up to 4, and including 4. I don't see it past the number 4. So I need a bracket at 4. And remember that domain and range go from least to greatest. So if you wrote this other way around, that wouldn't be correct. The graph is increasing from negative infinity to 2, and from 2 to infinity, we're decreasing. If you'll notice, I have the parentheses around the 2 there. I can't include the 2 because at the number 2, it's not increasing or decreasing. It just is what it is. So that's why it's got a parentheses there, in case you're wondering. In terms of symmetry there, this is not reflected over the y-axis. If I want to tell it was an odd function, that's where if you turn the image upside down and it looks the exact same, that means it's an odd function. This does not look the exact same when I turn it upside down, so it's not that. And where is the graph continuous? Again, if I look from left to right, if I put my pencil tip down, I can see it's continuous the entire way. So that's that. One last thing I want to talk about is how can I rewrite this graph as a piecewise function? Well, you can tell that this graph here, absolute value, looks basically like 2 lines here. See how I extended them here, we're in some red? But I just need to erase the red part. So let me just figure out, what line is this? This is the line that has a y-intercept of 2 and a slope of 1. If I look at this graph here, if I just continue it on, it would hit at 6. So it's got a y-intercept of 6 and it has a slope of -1. It's going down 1, right 1. So this is what it would look like as a piecewise function. This absolute value graph can be rewritten, the equation can be rewritten to be a piecewise function where you have pieces of 2 different graphs, 2 or more graphs, excuse me, put them together so that it looks like this graph here. So if I look at this graph here, it doesn't matter which one you list first or second, by the way. The graph -x plus 6, I would be looking at from the x values of greater than 2. So that would be this one here. When x is greater than 2, so 2 or greater, I see this graph. But I only want to see the other graph, x plus 2, when the x values are less than or equal to 2. And again, pick one or the other to have the equal to. They can't both have it. So here's the x plus 2 graph. And if I only look at this graph, this line of x plus 2, from all the x values that are 2 or less, that would give me this shape right here. And so that's what's known again as a piecewise function. So today we talked about absolute value functions and piecewise functions. And one last time so you can see the homework assignment if you need it. It's this date, Monday the 20th, and that's the assignment right there. So if you do that, then we'll be in good shape for our lesson on Wednesday.